Welcome to how AI processes information from rule-based logic to visual perception. In this video, we are going to be exploring how artificial intelligence understands and interacts with the world, first through logic and reasoning, and then through sight and perception. This is Abstraction Academy, brought to you by Shashank Shah. What is AI really about? Well, AI can do two main things. It can process information using logic, and it can perceive information by interpreting what it sees. Processing AI is about making decisions through structured reasoning. Perceiving AI focuses on vision and understanding images, objects, and surroundings. Early AI, so rule-based systems. In the early days of AI, systems were built entirely around human-written rules. These were called the rule-based systems or expert systems. So, they tried to mimic how human experts made the decision by storing facts and logical statements like, if X is true, then Y happens. A typical rule-based system has three parts. The knowledge base, which stores all the facts in the rules, the inference engine, which applies logic to make conclusions, and the user interface, which communicates results back to the user. Essentially, it's like a digital expert applying a long list of if-then statements, if you know how to code. One early example was diagnostic assistant. So it used hundreds of predefined rules to ask questions, analyze input, and recommend possible outcomes. Everything it did was based on logic programmed by humans, not learning or adapting. And rule-based systems rely on human-defined rules for problem-solving, utilizing logical flows to navigate decision-making processes, and all of these allow AI to execute tasks with clear parameters and outcomes. So, the limits of rule-based systems. Okay, but these systems did have big limitations even though they were all great, right? They were extremely hard to update when knowledge changed. They couldn't handle uncertainty or visual information, and every single rule had to be manually written, which made them rigid and inefficient. Like, imagine having an AI and you want it to be really smart. Imagine how many rules you would have to write. Let's say you write 10,000 rules. Imagine how much time it would take to not only just, if you even just have them in your mind and you want to write them all down. 10,000 rules, that's like 10,000 sentences. That's 10,000 if-then conditions. That would take forever and ever. So this is just a huge limitation, and this is why we had a shift. Okay, what did we shift to? The shift to learning AI. So because of those problems, researchers started building AI that could learn from the data. Like, you only put in a little bit of rules and it starts learning from all of those. So instead of being told exactly what to do, these systems looked for patterns and adjusted on their own. This evolution led to machine learning and neural networks. These are models that improve as they process more data. So the rule-based systems was the foundation of early AI. The expert systems were decision-making based on the rules from up here. And neural networks and deep learning are what we shifted to make those limitations not as bad, not as strong, because these limitations that we face, they were huge problems. Like, just to make ChatGPT, if we had the old rule-based systems, that would take 20 years to get GPT-2 ready. It would take forever and ever and ever and ever. So, what is computer vision? One major branch of AI is computer vision. It teaches machines to understand images and videos, similar to how humans use sight. Through computer vision, AI can detect objects, recognize faces, or even navigate environments. So it's like a visual detection, as you can see from this camera right here. And it's pretty much like a computer having eyes and a brain, which is really rare. Like artificially making a brain that can see and process. It was a huge step forward in the innovation. So, how does a computer vision work? Well, computer vision follows a process. First, an image enters as raw pixel data. Okay? Next, features like edges, colors, and patterns are extracted. And then finally, a classification step identifies what's in the image. For example, labeling it as a car or a dog or a tree. So let's say the raw images are starting point for the process. Like these are the images that are being sent in. Okay? The pixel data is what the image is transformed into. Then from this pixel data, we go and it starts looking for key features and like key identifiers and just like some specific characteristics about this image, and then running it through old data and running it through labeled data, it then classifies what it is. So for example, in this picture it would just be a girl with brown hair, right? And if you go check out our machine learning unit, it is actually the first video we go over this in much more depth. So I really recommend you go check that out. So, neural networks in vision. At the heart of computer vision are convolution neural networks, or CNNs, not affiliated with the news software. These networks analyze images layer by layer. Early layers detect simple shapes like edges or corners, while deeper layers recognize complex objects like faces or vehicles. You can find computer vision almost everywhere today, like literally anywhere and everywhere. So self-driving systems use it to detect obstacles and pedestrians, environmental scientists use it to analyze satellite images, and everyday apps use it to identify products or translate text from photos, like Google Lens. For example, if you have the Google app on your iPhone or Android or any other smartphone, if you have the Google app, if you click on the Google Lens button in the search bar and you hold it up to some text in a language that is not typically used on your iPhone. Like if I was to go travel to some Spanish-speaking country and I see a big piece of text that I have no clue what it says, I click on Google Lens and I hold it up. It will in real time translate what it says. I can take a picture of it, read it on my phone. So that is a real world use of neural networks in vision. So you can find computer vision almost everywhere today, right? Self-driving systems use it to detect obstacles and pedestrians. Environmental scientists use it to analyze satellite images. And everyday apps use it to identify products or translate text from photos, like I just stated. So yeah. Now we're going to go over processing versus perceiving AI. So let's go ahead and say processing AI uses rules and logic to make structured decisions. Perceiving AI uses data and learning to interpret the world visually. Both are essentials. Logic allows reasoning, while vision enables understanding. Combining logic and vision, the most advanced AI systems combine them. For example, a navigation system perceives road and traffic signs using vision, then uses reasoning to decide how to steer, when to stop, and where to go, right? In the future, AI will integrate reasoning, language, and perception seamlessly, and that means not only seeing or thinking, but truly understanding the context. This combination could lead to more natural, adaptive, and reliable systems that work alongside us in daily life. Thank you for watching. If you learned something new about AI processes and perceives information, feel free to share your thoughts or requests, and let's keep exploring how intelligence evolves. Good luck on the quiz you're about to take.